This video summarises the work undertaken on Portrayal within the aviation thread of OWS-9. This was focused on supporting the creation of Electronic Pilot Information Bulletins or ePIBs, and particularly the graphical representation of Notice to Airman or NOTAM information in map plates within ePIBs. At present, pilots are presented with a bundle of NOTAM information which might be relevant. Sorting through this is time-consuming and error-prone. A better presentation of information, visualised geographically, is more easily assimilated and will save time and reduce risk. The OWS-9 implementation is formed of two parts. The first part is the ePIB map definition capability implemented by Untitled, and is primarily an interactive workflow resulting in a set of ePIB map requests. The second part, implemented by Untitled, is the ePIB generation workflow, which is a multi-service processing activity resulting in the map generation. Let's first look at the definition process. This process uses a browser client exploiting Untitled portal technology. Thus, there is no need for any additional installed software or plugins on the client. There is a light services wrapper which is needed to support browser access to multiple services and provide a mediator to the core OGC services. These OGC services include a registry which coordinates which services are used in a multi-authority or region environment. There are also a number of web feature services delivering data for different flight authorities or regions. They are used by the client to provide an airport gazetteer and also to retrieve NOTAMs relevant to the airport selected. Lastly, there is a web processing service, which is the interface between the definition and generation phases of the workflow. The ePIB workflow is invoked from a standard browser. The user can enter part of the departure airport name, and the client initiates a WFS request, resulting in relevant options being presented. The user can also select a departure date and time. Next, the same process is enacted for the arrival airport, and the result is a geographical representation of the airports and the route in stylized form. Since the pilot needs alternate airports for both the departure phase and arrival phase of flight, and a NOTAM assessment of these is also prudent, these can also be entered. At this point, the user can access the relevant NOTAMs, and any NOTAM relevant is displayed below. The user can then invoke the ePIB generation workflow. The generation workflow shows how chained OGC services can be used to meet a complex application-specific requirement. The workflow involves firstly the ePIB client, which we have seen generating a number of requests. The Web Processing Service, or WPS, developed by Untitled, then takes these requests and processes them. Each request contains information on the geospatial and temporal extent of the map being generated. It also contains information on which airport layout feature types are required. Because the information could come from different web feature services managed by different authorities, the Web Processing Service executes a registry request to determine the correct source based on the feature type and geospatial extent. It then requests the relevant information from the chosen web feature service. The resulting geography markup language, or GML information, is assembled by the WPS together with the GML from the NOTAMs passed to it by the ePIB portal. The WPS then passes the combined block together with style information retrieved from the registry to the Untitled feature portrayal service. This generates the map image, which is then passed back to the WPS and onto the portal for integration into the ePIB HTML document and presentation to the user. As can be seen, the ePIB map image is integrated into the ePIB document and is presented together with a textual summary of the NOTAM cross-referenced to the image. This can then be delivered in HTML form or as a PDF or printed. This demonstration has shown how both interactive workflows and service chains with standard and customized OGC service components can provide an effective solution to the ePIB map generation requirement. The result is a document which is up to date, easily generated and assimilated, and has the potential to reduce pilot workload and the risk of accidents by making information clearer. It also allows the aviation architecture to deliver ePIBs to users who are not fully connected to the architecture, which is a key requirement while the industry transitions to more online services.